Welcome back, deep divers. So, if you've been anywhere online recently, you've probably seen those really glossy AI demos.
Oh, yeah?
You know, the voice assistant that feels genuinely present. It speaks naturally. It can handle interruptions.
Without missing a beat.
Exactly. It's captivating stuff. But, you know, for us builders, the question that immediately pops up is, how do you actually ship that? How do you build that kind of real-time, human-like conversation without, well, turning your whole tech stack into a tangled mess of spaghetti?
And that's really the mission for this deep dive, isn't it? We want to give you a map, essentially, a way to understand how to build these incredibly natural, real-time conversational AI experiences using the Gemini Live API.
Okay.
Because, look, this isn't just another endpoint you hit with a prompt.
Yeah.
It's a pretty fundamental shift.
Right.
Think about moving from, say, sending an email, that request-response model, to having a proper phone call, a persistent connection.
Ah, okay. Like a live line.
Exactly. And that streaming connection, it changes everything. How you design, how you think about latency, even how you budget for it.
All right, so let's unpack this. Let's get you building something real.
Great.
Today, we're diving into what the Gemini Live API actually is, how to navigate some of those core architectural choices, get into the practicalities like pricing and utility, and crucially, how to take something from a prototype stage right into a secure production environment. So let's kick off with the basics then. To really get our heads around this, what is the Gemini Live API at its heart? What's fundamentally different from, the usual API call?
Well, at its core, you can think of the Gemini Live API as basically a real-time conversation pipe with brains.
Good.
What makes it so different is that it's built on a persistent bidirectional WebSocket connection.
Right, WebSockets.
Yeah. So you're continuously streaming data, could be audio from a mic, video, maybe just text from your user. And importantly, the model on the other end isn't waiting for you to finish your whole thought.
Ah,
It streams back partial responses, like text tokens or chunks of audio, as soon as they're ready.
so it's incremental.
Exactly. That constant back and forth incremental exchange is what unlocks these next level applications. Think about a voice companion that doesn't have those awkward long pauses.
Right, the uncanny valley of silence.
Precisely.
Yeah.
Or like an on-device coach that can see what you're doing on screen and talk you through it in real time. Or real-time translators that actually feel like having an interpreter there, not just this turn-based thing.
That real-time bit sounds absolutely key. And you mentioned latency earlier, that sort of silent killer of presence. How does the streaming approach specifically help with that latency problem?
Yeah, that's critical. Latency is what shatters the illusion, right?
Yeah.
If there's a noticeable delay, that feeling of a natural interaction just evaporates. The Gemini Live API minimizes those round trips because it maintains that live session. You're sending little bits, small frames of audio, for instance, and the system starts responding almost immediately, incrementally. It feels like someone's actually listening on the other end.
Because they're reacting as you go.
You feel heard right away. And, to keep longer conversations making sense, the stack includes some really important capabilities. Things like voice activity detection, or VAD.
Okay, what's that do?
It basically figures out intelligently when the user is actually talking versus just, background noise or silence.
Ah, smart.
Yeah, and that works alongside robust tool use, function calling capabilities, and session management to keep everything coherent over time.
So stepping back, for someone building a product, how does this change what's possible? Or maybe even what users start to expect from AI interactions?
Well, the big insight here, I think, is that you're moving beyond those clunky single prompt interactions.
Yeah.
Where it felt like talking to a slightly slow answering machine.
Yeah, very transactional.
Exactly. Now you can build genuinely fluid, almost human-like conversations. It shifts the user's expectation, I think, from just a functional interaction to something that feels more, well, present, maybe even empathetic in some cases.
Okay, so we see why streaming in real time are so important for that feeling of presence. The next big question for any builder then is, how do we actually build this? What are the key architectural decisions we need to make up front? I gather there's a pretty big choice around audio generation.
Absolutely. And this is like the first major fork in the road. It really shapes the core feel of your user's experience. You basically got two main options for generating the audio response.
Okay.
First up, there are what we call native audio models.
Native audio.
Yeah. These are designed for, well, maximum naturalness. They generate this speech directly from the model's internal state. And the result, honestly, can be pretty stunning.
How so?
It just sounds less robotic, more expressive. And you can even get something called affective dialogue.
Affected dialogue. Okay, what does that mean in practice? Why is that a big deal?
It's a huge leap, actually. Affective dialogue means the system can subtly mirror the user's tone, maybe their emotional state, or it can adopt a specific tone itself for effect.
Wow.
Imagine an assistant detecting frustration in your voice and responding, calmly, or maybe sharing excitement. It uses those vocal cues to build empathy. That kind of nuance was incredibly hard just a short while ago.
Right.
So native audio models are probably best for products where the voice quality is absolutely paramount, like a really personal coaching app or sophisticated narration, maybe assistive tech that does a lot of talking.
Okay, sounds amazing. What's the catch?
The trade-off,
Mhm.
typically, is that these models are often in a preview tier,
Ah.
which isn't necessarily a bad thing. It just means they're iterating really fast, incorporating cutting-edge research.
Hmm.
So while they offer these amazing capabilities, you need to plan for that. You want rigorous version pinning, maybe careful canary deployments, knowing that things might evolve quickly.
Okay.
You'll see model names like Gemini 2.5/preview native audio dialogue in this category.
Gotcha. So high naturalness, but maybe needs a bit more careful handling in production. What's the alternative?
The alternatives we call half-cascade models. These are, I'd say, the production-friendly workhorses right now.
Okay. How do they work?
So these models take your audio input, convert it to text internally first, figure out what to say back as text, and then pass that text to a really high-quality text-to-speech, or TTS layer.
Ah, okay. So audio to text, then text-to-text generation, then text-to-speech.
Pretty much, yeah. The big advantages here are reliability, usually better logging capabilities, and critically, often stronger tool use integration.
Right. Tools being like calling functions or APIs.
Exactly. If your assistant needs to frequently call external functions, hit databases, manage complex tasks mid-conversation, this architecture can sometimes make that easier to manage and debug.
Makes sense.
The voice quality is still excellent, by the way, really good, just maybe a tiny notch below native audio in terms of that ultimate warmth or expressiveness. You'll see models like Gemini Live 2.5 Flash Preview in this bucket.
So this sounds like a classic kind of developer choice, doesn't it?
Yeah.
Balancing that cutting edge, almost human-like naturalness against maybe production readiness, reliability, and integration needs.
That's exactly it. And it's not just a technical choice, right? It's strategic. Are you selling the sheer magic of the voice itself, where the voice is the product? Or is it more about the utility, a reliable assistant that uses voice to get stuff done?
Interesting.
Knowing which one your product leans towards really helps guide you down the right architectural path and informs, your future operational planning too.
Okay, so let's say you've made that call on audio generation. What's the next big fork in the road? I understand it's about where you actually handle the WebSocket connection itself.
That's right. Your second major architectural decision is where you choose to terminate that persistent WebSocket connection. And this has big implications for latency, but also for control and security.
Okay, what are the options?
He's essentially got two main ways to go. First is client to server, direct to Google.
So the user's device connects straight to the Gemini API.
Yeah, exactly. Your front end, your web app, mobile app opens the WebSocket connection directly with Google's infrastructure. This is the absolute winner for latency.
Makes sense. Fewer hops.
Right. One hop, no proxy slowing down the stream. The main challenge here, though, is security.
Ah. Because you can't just put your API key in the JavaScript.
Absolutely not. You can never ship a static, long-lived API key directly to the client. That's a recipe for disaster.
So how do you secure that direct connection, though? If you can't ship the key, what do? You mentioned ephemeral tokens. How are they different from, say, a standard JWT?
Great question. The solution is you need to mint short-lived, single-use ephemeral tokens on your backend server first.
Okay.
Your client requests this token from your server, gets it back, and then uses that specific token just to open the WebSocket session with Google.
So it's like a temporary passkey.
Exactly. Think of it as a one-time use key that's only valid for initiating this specific session. It expires really quickly, maybe in seconds or minutes, dramatically reducing the risk if it were somehow intercepted.
And how's that different from a regular JWT?
Well, a standard JWT might grant broader access for a longer period. An ephemeral token for Gemini Live is typically much more tightly scoped. It's bound to a specific user, maybe even a specific model they're allowed to use, and that very short time window.
Got it.
The best practice is definitely to rotate them, make sure they expire properly, and meticulously log their issuance and use for security auditing.
Okay, so direct connection is fastest, but needs careful token management. What's the other approach?
The alternative is server-to-server, where your own backend acts as a proxy for the stream.
So the client talks to my server and my server talks to Google.
Precisely. Your client streams the audio or text to your server, and then your server opens the live session with Google and forwards the data back and forth.
What are the benefits there? Seems like it adds a step.
It does add a step, and therefore some latency, but the big advantage is control.
Yeah.
You get centralized logging right on your back end. You can shape requests before they even hit Google. You can enforce custom policies, maybe based on user roles or other business logic, right there.
Ah, okay. So more visibility and governance.
Exactly. For some products, that extra bit of latency is an acceptable trade-off, especially if you need really fine-grained observability or control over every interaction. Maybe you need to gate access to certain tools or data based on complex internal rules. This gives you that central choke point.
That really clarifies that trade-off. Absolute speed versus more centralized control and visibility.
Okay, so we've navigated these big architectural choices. What's often the next major hurdle when moving from a cool demo to a real-world app? My guess is cost.
You guessed right. Cost is always a factor, isn't it? It's like the quiet product manager in the room. And with real-time streaming, understanding the pricing model early on is absolutely crucial.
So how does Gemini Live pricing work? It generally depends on two main things: the modality text, audio, video, and the direction input versus output.
Okay.
As you might expect, text is usually the cheapest. Audio and video cost more because, well, you're moving more data, and models doing the processing are often more complex, especially for fast responses.
Right.
And you pay separately for input what the user sends to the model and output what the model generates back.
Got it. Can you give us a rough idea?
Sure. So looking at the paid tier pricing table for, say, the Gemini 2.5 Flash model, and remember, these numbers were current around August 24, 2025, so always double-check the latest docs.
Of course.
Text input was around 0.50 cent per million tokens. But audio, image, or video input jumped up to about $3 per million tokens.
Okay, quite a difference.
Yeah, and then for audio output, you were looking at something like $12 per million tokens.
Wow, okay. Output audio is significantly more.
It reflects the computational cost of generating that high-quality, low-latency speech.
So let's make that tangible. What does a typical session cost?
Okay, let's try a quick worked example. Imagine, say, a 5-minute voice conversation using one of the Flash family models.
Right.
If the user talks for about 5 minutes in total, that's 300 seconds of audio input streamed, and maybe the assistant speaks back for about half that time, say 2.5 minutes total output. You'd apply those per million token rates for audio input and audio output for your chosen model. Doing the math, you'd likely land somewhere in the low single-digit dollars per session for that kind of rich real-time interaction.
That's actually really interesting. So the aha moment here seems to be that your UX design, like when the AI speaks, how verbose it is, isn't just about making it feel nice. It directly impacts your cost.
Precisely. Your UX design becomes a direct lever on your unit economics.
Wow.
Every choice about if the AI speaks or maybe uses a silent confirmation instead translates straight into dollars and cents. It turns UX from just a feature into a core business strategy.
So designing for conciseness or using nonverbal cues where appropriate can actually save money.
Absolutely. Design for silent confirmations when just a visual checkmark will do. If your assistant mainly provides text responses and only uses voice occasionally, your costs will be significantly lower. Understanding this up front means you can design for both a fantastic experience and a sustainable budget right from the get-go.
Okay, super important point. Now, demos are great for showing off the voice, but real assistants need to actually do things, right? How do we make a Gemini Live assistant useful beyond just chatting? How does it accomplish tasks?
Yeah, this is where it gets really powerful. You need tool use, function calling, and some form of memory.
Right.
The API fully supports these. You define tool schemas, basically descriptions of functions your code can perform, what inputs they need. Then, during the conversation, the model can decide to call one of your tools.
Like check the weather or look up this order.
Exactly. The crucial part is that your function needs to execute and return the result quickly, ideally within the latency budget for that conversational turn, so it doesn't feel like the assistant went away for coffee.
Keep the flow going.
Right. And for memory, you'll typically store relevant facts from the conversation.
Oh.
Maybe in a simple key value store, linked to the user and the purpose of the conversation. Keep it scoped, make sure it's auditable, and critically, make it easy for the user to clear it.
Privacy first.
Always. But this combination is what turns a chatbot into a real assistant. You ask for your order status, it calls your backend function, gets the data, and tells you your order shipped yesterday, instead of just, making something up.
Or saying, I can't help with that.
Exactly. And beyond single tool calls, you need good session management. Long conversations can get lost without structure.
Right.
So use the session APIs to carry context system instructions, telling the AI its persona or goals, the conversation history across turns. A good tip for cost and speed is maybe summarize the key points periodically, not necessarily after every single turn.
Okay.
You can pin important things like safety rules or style guides in the system messages. And if the conversation shifts to a totally new task, maybe checkpoint the old session state and start fresh with a clear objective.
Got it. So that's how you transform it from just a voice into a capable assistant that can actually do things. But even with all that power, we have to come back to something you mentioned earlier, something you really feel: latency.
Ah, yes. The quiet product manager.
That awkward pause that just kills the mood. How critical is it, and what can we do about it?
It is so critical for that feeling of presence. Generally, anything over maybe 200 to 300 milliseconds, that's like less than a third of a second between when you stop talking and when you start hearing the reply, it just feels wrong.
Yeah.
It breaks the rhythm of natural conversation.
Yeah, you notice it immediately.
You do. So some concrete advice for developers.
Okay.
First, capture your microphone input in small chunks, small buffers.
Yeah.
And crucially, send them as you capture them. Don't wait to accumulate a whole second of audio.
Stream immediately.
Second, if voice quality and responsiveness are absolutely core to your product, strongly consider that direct client-to-Google connection to minimize network hops.
Oh.
Third, render partial results. As soon as that very first chunk of audio comes back from the API, start playing it through your TTS system. Don't wait for the whole sentence.
It's sound flowing.
Exactly. And finally, keep your tool functions lean and fast. If your assistant needs to call a function and that function takes a second to run, that's a second of dead air.
Right. Adds directly to the perceived latency.
Every single millisecond you shave off helps maintain that illusion of presence. That really is the core promise of the whole Gemini Live API stack, enabling that fluid, present interaction.
It's fascinating how it's not just about raw speed, but about preserving that feeling of a real back and forth, making the tech just disappear. So we've got the architecture, we're thinking about cost and utility, we're fighting latency. What about moving from that cool proof of concept to a truly robust, shippable product? What are the day two considerations?
Right, because day two always comes. You absolutely cannot fix problems you can't see. So structured logging is non-negotiable.
What should we be logging?
At the session, boundaries start and end times. Log the specific model name you used. The token count is broken down by input, output, and modality. You need per-turn timing data. How long did the user speak? How long did the AI speak? How long was the silence in between? And critically, if you're using tools, log the latency of each tool call.
Okay. What about the audio itself?
For privacy, generally don't log the full audio stream. Instead, maybe sample the audio levels, check for clipping or long periods of silence that might indicate a problem. And definitely build traces for when things go wrong and need escalation, maybe to a human agent. Keep the transcript with explicit user consent, always.
Got it.
This data is what lets you answer those inevitable questions later. Why was this interaction slow? Which function is failing? How much did this user session actually cost us?
Makes sense. And tied into that, especially with live voice interactions, security has got to be top of mind. How do we ship this powerful tech without creating leaks?
Paramount importance. Cannot stress this enough. Number one, never ever ship a long-lived API key directly to the client-side code, like in your browser JavaScript or mobile app.
We covered that use ephemeral tokens.
Exactly. Use those short-lived, tightly scoped ephemeral tokens, minted securely on your backend, bound to the user, the model, the time window.
What else?
Scope your tools meticulously. Think deny by default. Only grant the AI the specific capabilities it absolutely needs for a given task. Implement robust rate limiting per user, per IP address to prevent abuse.
Good point.
Ensure any recordings or sensitive data you do store are encrypted at rest. And critically, make data deletion requests a first-class, fully tested feature. Users need control. The key insight for security here isn't just the tech safeguards, it's thinking about the human element. How could someone misuse this? And how do things like ephemeral tokens directly block those potential attack vectors?
Okay, solid advice. Looking ahead now, this whole platform, the space, is moving incredibly fast. What should builders be keeping an eye on? What's likely coming down the road?
Yeah, it's definitely dynamic. You should absolutely watch for ongoing model upgrades. Expect improvements in native audio quality, likely broader language coverage over time.
Mm-hmm.
Look for tighter integration with tool use, making it even easier and more reliable for models to call your functions. Also, keep an eye out for better mobile runtime primitives, things that can help reduce latency even further right on the device.
Okay.
And, of course, always track the official Gemini Live API documentation for any changes to token policies, new features, or controls over the responses.
So stay informed.
Definitely. And the beauty of having a clean architecture, based on those choices we discussed earlier, is that you should be able to adopt many of these improvements without needing a massive refactor every 6 months.
Right. Future-proofing to some extent.
Exactly.
Yeah.
And it really reframes your role as a developer, doesn't it?
Yeah.
You're not just writing prompts anymore. You're designing a conversation. The goal, ultimately, is to build the kind of conversation you yourself would actually want to have.
That is a powerful way to think about it. Shifting focus from just the instruction to the entire interactive experience, making it feel alive.
Well, we have covered a ton of ground today. Really laid out a map, I think, for building with the Gemini Live API. We went from its core streaming nature
Mm-hmm.
through those critical architectural forks in the road, talked about managing costs smartly, making assistance genuinely useful with tool,
Right. The utility part.
optimizing for that crucial feel of low latency, and finally, how to deploy it all securely and robustly.
It's been a great deep dive. And maybe, as you get started, I can leave you with one sort of provocative thought.
Please do.
When you open your very first session with the API, build that basic loop, say hello, and then just listen. Listen for that exact moment when the reply starts to feel natural, effortless.
That feeling, that sense of a genuine fluid interaction, that is your North Star. Because the Gemini Live API isn't just about turning text into speech. It's about turning AI from a kind of static form you fill out into a real presence. Your challenge is to capture and cultivate that feeling.
An incredible challenge and a huge opportunity. So the message is, get started. Build that minimal voice loop today. Maybe swap in native audio tomorrow if it fits. Add one simple tool the day after.
Iterate.
Iterate, exactly. Keep pushing that boundary with the Gemini Live API as your toolkit. Thank you so much for joining us on this deep dive.
My pleasure.